represent 96,500 coulombs, and our current here, they gave it to us as 4.5 ampere, and our time, we had 105 minutes multiplied by 60 in order to convert it to seconds. What are we having here? What do we have here? 105 times 60.
6,300.
So we have 6,300 seconds here. All that is needed is for you to substitute these values into this equation here and solve for your m. And by so doing, I believe we've all gotten the answer. We've all gotten the answer. Good. I can clean the board and solve for B. Okay. Is that an extra one? Filled already? Okay, I said B. Number of moles is equals to what? Mass over molar mass. That is the mass we got here in A. That happens to be 57.88 grams divided by the molar mass of gold. That happens to be 197. I'm cleaning here. Good. Finally. Okay. Number of moles is equals to mass all over molar mass. We got the mass to be what? 57.88 all over the molar mass of gold, 197. This should give us 0.033 something.
294.
Is it 29?
Yes.
Approximately 0.3. I'll leave it like that there. Number of moles. Approximately 0.3. You guys are welcome. Divine. Remove that, remove the book and the bag. Enter there. Divine. Get up. 1, 2, 3, 4, 5. 1, 2, 3, 4. I'll do a opportunity. Choose where you want to sit down, apart from this side. Choose where you want to sit down. I know say you don't be eye one person before. Choose where you want to sit down. Ah, you sure sit down there you want to sit down. Vic. Go close to the ground. No fear. Good. Those of you that came late, I already told you guys that we'll be looking at organic chemistry 2 under chemistry and equilibrium of forces under physics. But as if I knew that most of you are standing outside, I decided to while up time with few questions that has to do with electrolysis. So that one you don't miss and small. But I'm still going to give you one more question under electrolysis before we move down to what we have properly for today. Okay, we are done with number of moles, right? We've gotten answer. I've gotten C signified. I've gotten C 1, 2, 3, 4. What do you have as C, Victor? 1.2, Joanne?
C. 598.7 seconds.
598.
0.7.
Victor, right? You also have same value. What do you have there? Same value? Same value. Ah, that one, like the guy. Akin, what's the value?
598.8.
Okay, good. Good. So I'm not going to do that. I'll only give you the second question because I don't have time. This is what you've been taught already. Let me teach you electrolysis. I just want to help you brush you up small. Second question under electrolysis. Then we call it a day under this. Calculate the current. Calculate the current calculate the current that must be passed. Calculate the current that must be passed into a solution of aluminium salt. Here, instead of gold salt, we are using aluminium salt as the electrolyte. As what? The electrolyte. I hope you all know that electrolysis is what? The decomposition of an electrolyte, right? Yes. So what we are saying, what this question is saying, we should calculate the current that must be passed through this aluminium salt. We don't know the aluminium salt. It could be aluminium chloride. Aluminium chloride is an aluminium salt. What is the current that must pass through it in order to split into anion and cation respectively for migration to anode and cathode? That is what we are saying here. Because the essence of electrolysis is for your electrolyte to split, but it doesn't just split. When you pass current through it, it will split into positive and negative, known as what? The cations and the anions respectively. And after splitting, what happens? It migrates into the anode and the cathode. Okay? For 1 hour, 30 minutes, in order to deposit, I started by saying calculate the current that must be passed into a solution of aluminium salt for 1 hour 30 minutes in order to deposit 1.5 grams of aluminium. In order to deposit 1.5 grams of aluminium, they gave to us atomic mass of aluminium 27. As usual, they gave us 1 Faraday to be what? 96,500 coulomb. This happens to be your formula box. You are asked to calculate the current. So most times you might be asked to calculate the mass. On the other hand, you can be asked to calculate current. Sometimes you might also be asked to calculate time, number of moles, and so on. All these parameters should not be left out. You might be asked to calculate any of the parameters I have mentioned. This is the second question under electrolysis again. The first one, some of you are looking at me. This is the second one. Calculate current. What current must be passed through aluminium salt for 1 hour 30 minutes in order to deposit 1.5 grams of aluminium?
So,
yes?
1 ampere.
You got current as 1 ampere?
0.9.
Okay, approximately you got 1. I don't really know if that happens to be the answer. So while waiting for others, just go through your work and see if there's anywhere you got it wrong. Then others, I need confirmation or objection as to what Hakim said. He said he got 0.9 and approximately to the nearest whole number, he got 1 ampere. Since we are calculating or solving for current, who can attest to the fact that Hakim is correct? 1 ampere. I'm waiting. Here, take note, that formula I gave to you there, you can also use that formula. M here, look at it. Mass, they gave us the mass. Okay, we don't know the mass. Okay, they gave us mass here. Look at mass. 1.5 all over the molar mass. What is the molar mass of aluminium? 27 is equals to IT. I, we are looking for I, which is the current. Our T here is the time. 1 hour 30 minutes. We need to convert it to seconds. Then here our number of Faraday is going to be 3 because aluminium is trivalent. Yours is 2.9. 2.9. Approximately 3. Good. Hakim, check your work. I'm not saying the 3 of you are correct. I'm yet to confirm that, but since I'm having majority of the students going for 2.9, let me just assume or be forced to believe that the answer is 2.9, except proving otherwise, either by a different student or by my humble self. I've given the formula straightforward. Mass 1.5, molar mass 27. I is what we are looking for. Our T here is going to give us a total of 90 minutes. A total of 90 minutes. You have to convert your 90 minutes to seconds by multiplying by 60. Then our number of Faraday is going to be 3 because aluminium is trivalent. Having said this, what is the challenge here? Mass equals to 1.5. Substitute the values. Molar mass is equals to what? 27. Number of Faraday for aluminium here is trivalent, so it's going to be 3 times 96500. And our I, we don't know. That is what we are solving for. Our T here is a total of 90 minutes. Remember, you have to convert your minutes to seconds by multiplying by 60. Then substitute all these values. Substitute these parameters into this equation. Simple and straightforward. Alan, are you true? Came late. Titi, are you done? My friend seated here. Have you seen me before? Okay, you're a new student. Good. What is your name? Emmanuel. God with us. Good. You're welcome. Welcome. Are you true? What is your answer? 2.98.
So I think it's I got 3.3.
Hold on. You got
3.3.
3.3. Okay. You want to say something?
It's actually 2.98. The way you approximate now between 2 and 1.
Okay. I'm going to confirm that. Initially, he got 0.9. Secondly, he got 3.3.
Wait, sorry.
Okay. Those of you that have not said anything in my class, it will get to a point where I'll be pointing you. I'll point you. This class should be an interactive class. Blessing, you are lost. That is the disadvantage of coming late. Okay, so that we will not waste the whole time here before moving into what we have for today that happens to be aromatic hydrocarbons. Let me do justice to this. Let's know those that got it and those that, hey, look up. This is what I want to do. I want to use a different method because this method I gave to you is very, very simple, just straightforward. For the YX student, you might be asked to either use second law of electrolysis or make use of the electrochemical equation specifically. So the first question, we used the second law of electrolysis. So let's see how we can or will be able to use the what? Electrochemical equation into solving. Since I am asked to look for current, first let me write out the how is it called, the electrochemical equation. Aluminium being trivalent is going to give away 3 electrons to become metallic aluminium. You don't understand what I did here. Aluminium is going to give away these 3 charge. This is it here, to become metallic aluminium. Can I move on? Can I move on? Who don't understand? Look up, it's very, very simple. Assuming the question is referring to, okay, let me go back to gold. The equation for gold is going to be like this. Au plus gold is monovalent. Monovalent. 1, the valency is 1, there is plus 1 here, but because it is 1, the 1 becomes invisible. So, but since we are learning, permit me to put it there. So it's going to give away this 1 electron, look at it here, to become metallic gold. Mr. Victor, is it because you are using aluminium and gold? Both of them have AA. Mr. Victor, use a different thing. Assuming the question is referring to zinc, zinc is divalent. My equation is going to be like this. Zinc 2 plus is going to give away the 2 electrons to become metallic zinc. So I can keep going on and on and on and on. So in essence, the charge that metal is carrying is what is going to give out to become a metallic element. Can I play now? Good. So I can play here. Let's focus on what we were solving. From here, what this translates into is this. What is the mass of aluminium? What is the mass of aluminium?
27.
That means 27 grams of aluminium is going to be giving away 3 Faraday to become metallic aluminium. 3 electrons. 1 electron represents 1 Faraday in this case now. 2 electrons, 2 Faraday. 3 electrons, 3 Faraday, and so on. So here now, look at it here. If I wanted doing it, we did it with gold. Look at gold own. Au plus is going to give away 1 to become ordinary gold. What does it translate into? It means 197, that happens to be the mass of gold, is going to be needing 1 Faraday to become a metallic gold. That is it there. Are you guys following me? Good. I've spent almost more than 30 minutes for this. We've not entered what we need to do for today. So I need to be fast. You guys have done this topic before. So this is what we have here. So it means 27 grams is going to be giving me 3 Faraday, which is 3 times 96,500. Who don't understand up to this point first? 27 grams is going to give me 3 Faraday. Am I there? Okay. So it means 27 grams is equals to what is 96,500 times 3?
289, 500.
289 500 coulomb. Eh? Okay, that's what we are having here. Take note, this is the formula we want to use to get our distance. Look at me here, this is it. Q is equals to IT. We know this formula, right? This Q stands for the quantity of charge. I stands for current, which is what we are looking for. We know our T already. So what I am trying to do here is to look for my quantity of charge. I am not going to use this quantity. This quantity was when the mass of aluminium was 27 grams. But the question says the mass of aluminium happens to be 1.5. So you are going to look for the quantity when the mass is 1.5. That is going to serve as your main quantity. You don't understand. Look at me here. What I did here, since I've known that they've given me the mass of aluminium to be 27 grams, I need to know the quantity that 27 grams would produce. And from this equation, 27 grams is going to produce 3 Faraday. 1 Faraday is 96,500. It means 3 Faraday is going to be 96,500 times 3. That gave rise to what? This here. Am I communicating? But I am not going to use this quantity because this quantity is for 27 grams. I am going to look for the quantity that 1.5 grams that the question stated produce. That is what will serve as my Q. So once I get that, I'll substitute here into I times T. You know your T already, 90 minutes, which is 90 times 60. That should give you your time. Having known your time, having known your quantity, you should be able to get your I. Make una draw, get answer for me. Those who never get out. I'll clean here. You need to copy anything here.